Hi, and welcome to this tutorial where we'll be making this effect replicating Wanda's magic. I've worked as a VFX artist on several movies and shows, including Marvel ones for 4 years, and have also created personal projects that have been highly requested to make a tutorial on. If you're completely new to Houdini, we have a beginner series right under this tutorial where you can learn with no prior knowledge required. However, this tutorial should be easy to follow if you have a base knowledge of the software. If you're interested in our work or want to request a tutorial, you should check out our social media. On Instagram, we host votes for our next tutorial, which is how this effect was selected. As these tutorials take a lot of work to make, we would really appreciate if you liked and subscribed if you want to see more. Alright, let's get started. As you can see, I'm using Houdini 19.5.303, and if you're following along and see that some of the notes are slightly different, I would suggest updating to this latest version. However, if you're using a newer version, you'll be able to find documentation online to see the slight difference, so anyone should be able to follow along. And let's start by going into File, New Project, and I'm going to call it Wanda Magic Tutorial. And I like just Control A, Control C to copy this, so that I can Control Shift S and paste this in as my hip name as well. Let's see, so I double click on this, Wanda Magic Tutorial, and accept. And now you can see if you save and go up a level, this is all saved correctly with a good structure. And we're going to start by placing down a geometry node. And I'm going to call it Wanda Magic. And I like coloring my main one purple, so I'm going to do that. And I'm going to start by placing down a sphere and make it a polygon. And I'm just going to bump the frequency a bit. And we don't really know what scale we want this yet, so I'm going to set it to 0.1, as I know a radius of 0.1 is around the scale that we want this to be. So we'll start with that. Now the first kind of effect from Wanda's magic we're going to recreate is the core particles that are very concentrated in the palm of her hand, and they're kind of just moving around their own center. So we're gonna start by creating a points from volume, which will just create a bunch of points inside of our sphere. And I'm gonna start by maybe 0.05. You can see if you press D for display, I'm actually gonna make my background dark. And if you go to geometry, no, it's actually on guides. If you click draw FPS, it's nice to have the FPS counter. But more importantly, this geometry information, put this to always on, so you can always see how many primitives or points you're visualizing in the viewport. It's a very handy tool that I think everyone should always keep enabled. And when I have this enabled, I can now see I have 4,000 points, which should be a real-time simulation on my computers. So I'm going to set the jitter scale to 1 as well. And we can use this to start testing out the behavior of our particles and start playing with the pop simulation. And next, I'm just going to feed this right into a pop network. And I'm just going to jump into the pop network. And by default, this scatters onto surfaces, but we don't have any surfaces. We just have points. So I'm going to set the emission type to all points instead. And I also like turning off the guide. And as you can see now, nothing really happens, and that's because we don't have any sort of velocity in the sim, and there's nothing happening at all. But if you go out, you can see that it's constantly adding more and more points to the simulation. That's because every frame it's emitting all of these 4,000 particles. So, and we don't really want that, we only want it on one frame. I can demonstrate this by just putting down a pop wind and having a little bit of noise, and you can see that this is now constantly going to be emitting particles. But we just want the first frame, and you can do that by going into this impulse activation, which is basically controlling if it's emitting or not. And if you set this to $SF is equal to 1, you'll make sure that SF stands for simulation frame, and this will only emit as long as the simulation frame is equal to 1, which you'll see on the first frame of the simulation, which is frame 0. This will emit, and then on the next frame it's set to 0, so it'll only emit on that first frame where we want it, and that's exactly what we want for the simulation. Now, what we want to do with the simulation is we don't want the particles to die off like most simulations. We actually want them to always be living and just circling around this center point like I was talking about. And to achieve this, we're going to import our geometry that we have here, and we're going to make sure they're always trying to come back to the surface or inside of this geometry. And the easiest way to do this, or the cleanest way, is to put down a null here, so we can point to this, and I'm just going to call it goal. And now if I go back into my popnet and I'm gonna set this noise to a lower swirl size so that it doesn't go in as big noise shapes, and also a lower amplitude, just so we can test if we're able to maybe a bit more, just so we can test if we're able to make this always come back. Because right now it's just gonna keep going in random directions. Well, not random, in noise directions forever. And I'm gonna use a SOP solver in my simulation, which allows me to use any sort of SOP nodes inside the simulation, which is very handy. So I can use an object merge to point back to my goal object, which is right here. And then I can call this in goal, and I can use an attribute wrangle to write a little bit of script to make it always be every point. If it goes too far, it just comes right back. And we're going to use a few functions for this. The first one is min position, which is getting the minimum, or it's getting the closest distance from one point to the surface of this geometry right here. And let me just demonstrate this. So if I go in here and I write at p, or sorry, it's not getting the closest distance, it's getting the closest point on the surface. So if I write at p, which is our position of the particles, is equal to minpos, which is the function, 1, which is the one input, so it's 0, 1, 2, 3, and we're gonna be reading from the position of each particle. And if I set the position of a particle to the closest position of the surface, I need to end it like this. You can see every point just gets stuck on the surface of the sphere. But we don't, obviously, we don't want to stick it there. We just want them to slowly get closer to it, and it'll kind of like bounce in between the surface and the inside. And we can do that by storing this as a vector instead of just setting it directly. So we'll call it vector p is equal to this position. So now every particle knows where the closest point is. And what we can do is we can set our velocity and add on top p minus at p, which is the distance, or it's basically the difference between our position and the position here. And if we do this, I think it'll kind of, yeah, you'll see it. It starts, what's happening is the further it gets, the larger this number becomes, the distance between the position and the closest distance, and it'll just get sucked in. And if it's really close, it won't be that big, so it'll kind of keep going away until it gets too far. So this is a really nice and easy way to always keep the points at the center, and it creates really interesting shapes when we have a bit of noise like we do here. So in order to control this better, we can create a channel inside of our attribute wrangle, and which will give us a slider, and we can do this by multiplying by channel and parentheses and then write mult inside, just stands for multiplication. And if we set it to 1, it's just gonna behave just like it did before. It's gonna be the same effects, but if we set this to something higher like 5, you'll see the effects becomes a lot stronger. Creates this kind of an interesting pulsing effect. But in our case, I'm actually gonna set this to around 2. So I want it to be pretty strong, but not too strong. And the pop wind, and also to be a little cleaner, we can also just call this set goal, because it's nice to name your nodes to keep track of them properly. And this is just an old error. And the pop wind, we can also set a little bit stronger. I'm going to set this one to 0.6 with the swirl size of 0.25. And let's see what this gives us. That gives us something like this, but we do actually want this to be even faster, and we can do that by setting the substeps. I'm going to set the substeps to 3, and also the time scale to 3. But if I set the substeps to 3, it doesn't, like, let's start with actually with the time scale. If I set that to 3, you'll see it's a lot faster because everything is moving faster, but it's not able to catch the particles as fast. So if I set the substep to 3 as well, now it's going to catch them. It's moving around really fast, but I found this looked a lot better with the actual effects because it's just more violent and a cooler effects overall. And the last thing I'm going to do is I'm going to set the swirl size, sorry, the pulse length of this noise to 1.8, which is basically just making it not change as often so that the shapes stay a little bit consistent, a little bit more consistent, I should say. So that gives us this, which is going to look pretty cool when it's rendered out with motion blur. and everything else. And I'm gonna go out and I'm just gonna call this one core pop sim. And in order to, now it's gonna already export the particles by default, but if you have collision objects, it's gonna export them too, as this is just set to exporting everything. So I'm just gonna call this pop object and then start to make sure, so it reads pop ob and then it's gonna export everything after that. And this always ensures that we only get the particles. And I'm also gonna delete a few things off this that we don't need. Actually, one thing I forgot, we're actually inside the subsolver, we're also going to store an attribute called distance, or just dist. And I'm going to write at dist is equal to length between our position and the position that we gathered earlier from the minimum position function. And this is we're going to use this later because this is a really handy attribute to have because it's going to tell us how far each point is from the surface, and we can use this for coloring or making sure that these aren't as visible because we want to just see the core. And in our attribute delete, we're actually going to delete everything except for this distance attribute that we just created. And you can do that by just writing this and then clicking delete non-selected. And if you click info, let's see, you'll see that we have just this attribute, and of course position, because you can't delete the position of them. And next we're going to do a file cache, and I have a bit of a custom file cache, so I'm just going to reset it so we're all working with the same one. There we go. And the one thing I would recommend turning on in a file cache when you're working with simulations is going into advanced and opening the save and clicking initialize simulation ops, as this will ensure that every simulation always just resets and cooks from scratch when you're doing a cache to make sure you don't get any old small blue caches here saved in to your disk. And I'm going to connect it and just call it cache core pop sim. And another thing I'm going to do is I'm going to link the start of the sim with the start of the cache so that when I'm going to add some pre-roll a bit later, I'm going to make sure that we actually catch that in the sim as well in case we need to use it. So before I cache, I'm going to set this to 120 to make sure I only cache the frames I need, and then I'm going to hit save to disk. And it should be pretty quick, even with 3 steps, and obviously it just saves what we already had. And the reason I'm not saving the velocity is because I'm just going to recompute the velocity after the fact, which I can do with the trail node set to compute velocity. And I'm doing that because I find that the velocity, when doing super fast simulations with lots of substeps, aren't really that accurate. As you can see, this is the velocity I'm getting from the simulation, whereas this is the real velocity I'm getting from trailing it. And we don't need to match ID or anything because it's always just got the same point counts because none of them are dying or being born. And we want obviously the real velocity when we're going to calculate the motion blur here. And I'm going to set it to central difference, as that will calculate the velocity a frame back and a frame after, as this is a little bit more accurate when you're doing velocity again, especially for fast moving objects. Okay, let's start actually shading these particles now and making them look nice. And by the way, just ignore this version counter. This is just, again, something custom. And before we're gonna do the shading, I'm gonna just simulate this with a lot more particles. And I know for the final sim, I want around 150,000. So if you lower the point separation, 0015 for me works. And I'm just gonna version up once. It's good to keep track of all the versions. It just makes it easier to go back and compare, and if you ever need them, they'll always be there. And this should, yeah, again, be pretty quick. And here we have them. I'm also gonna go back into my velocity here and lower it to 0.3, as that'll make sure when we render this with motion blur, it'll be a bit sharper, as when they're moving super fast, it's gonna be a bit too blurry for what we want. Now, next thing is I'm gonna create an attribute wrangle and start by setting the p-scale of the particles. Just write that p-scale is equal to channel, and I'm just gonna call this one p-scale, so that we get a nice slider to control. And when you set this to disk, usually you can see them, but I'm in wireframe, so I'm just going to press W, or you can just hold here and set smooth shade, for example. And we can now control our p-scale, and there's a lot of them, so we want really small ones. And if you middle mouse and go to the bottom here, it's an easy way to control them. I'm going to set them to something pretty low, maybe 0.003 to start. And I'm also going to set an alpha. So alpha is equal to channel alpha. And this is the transparency of them. P-scale is the size of them. And as you can see, what's nice if we have a low p-scale and a low alpha, you can see when there's a lot of particles stacked up, and we get this nice shaded effect. This looks really nice, even just in the viewport. And lastly, I'm going to set the color. I'm just going to go simple red. So 1, 0, 0, RGB, red set to 1, everything else is set to 0, and we get a red color. And we'll actually shade this in Nuke when we do the compositing to make it look nice. And I'm going to desaturate it a bit so the glow works properly. But yeah, that's a good start. I'm going to set the alpha to 0.015. As usually, when you render it out, I actually like underexposing it a little bit, making it a little bit too dark, as I find that when you're compositing, it's easier to bring it up than down, which is kind of opposite of a lot of things when you're compositing. But for particles where they're stacked on top of each other, I find if they can get blown out if they're too stacked, then it's hard to bring down the brightness and get more detail, but you can always go higher. And I'm going to set the particle scale to 0015 for now, which might look a little bit too bright, but we're going to do some further reduction a little bit under. And I'm just going to call this set attributes because we're setting some attributes. And next, I'm going to do an attribute noise. That's not it. Attribute noise on these particles, where I'm going to create a noise, which I'm actually just conveniently going to call noise, which is a float. And in order to visualize it, you can click on this this little button right there. I'm going to make sure it's a float because I want the 1D noise. And the element size I'm going to set even lower because we're working at a pretty small scale here. 0.09 or 0.0 or 0.1 is good. I'm going to set the pulse duration, which you find under animated noise, to 0.25, which will make it change very fast. As you can see, the colors are changing very fast right now. And I think that's it. I'm going to go into write another angle, and I'm going to multiply this by the alpha. So what I'm trying to do here is I'm just trying to break it up even more. So mult noise alpha, and I like just calling this one noise because we're getting a noise called noise. So at alpha is times equal to channel ramp, or ch ramp, and I'm gonna just call the ramp ramp, and it's based on our noise attribute. And click here to create it. So what this is doing is this is ramp taking our noise, which is already going from 0 to 1. Positive and min max is kind of the same as the default values. And it'll multiply where there's low noise. It's gonna multiply the alpha closer to 0, and when the noise is high, it's just gonna keep it at 1. But in order to create some interesting shape, we can actually pull this slider down like this, so that we're kind of cutting off the lower values of the noise, and making sure that the alpha is not seen on those lower values. And this just creates some breakup in it, and leads to a bit more interesting shapes. And for the final value for this, I'm going to go with around here 0.34. And now I'm going to use the attribute we stored earlier in this, the only thing we stored, called dist, which again is the distance from our surface to, or distance from our particles to the surface. And what I want to try here and do is, I saw that when I rendered it, I didn't really like when they went too far. So I'm going to try and keep them close by using this attribute and constrain their distance a bit. And we can do this by, again, affecting the alpha and multiplying it by a channel ramp. Actually, let's start by fitting our distance attribute to fit at dist between 0, as it's 0 is the minimum value, and channel max dist between 0 and, or actually 1 and 0, as we want it when it's, so when the distance is 0, that means it's closest to our surface, and we want to keep that. Whereas when it's high, it's going to be further away. So let me click here so we can, or actually click W so I can see this. And this is kind of what we wanna stay in between. And if you keep this one pretty low, it's gonna cut off everything that's higher than this value. But generally, that's a bit of a sharp cutoff. Let's see, I'm gonna 0.5. 0.55 I find worked nice. So I can use a channel ramp let's see, I'm going to call this ramp and do a comma there and then add one parenthesis at the end. And I can make this one a little bit smoother than just linear by adding a point here and then selecting all my points and choosing B-spline. And if I click here, I can now do a nice smooth fall off or a sharper fall off if I want to. I'm just going to do something like this. And this is a subtle effect, but subtle effects stack up together and makes a nice effect. So this is what this will do. And I'm going to call this one fade alpha. Now, one of the last things I'm going to do is I'm going to do an attribute blur on these particles. And it seems to be counterintuitive, but when you do an attribute blur on the position of a particle, it'll actually tighten up their location relative to each other. And you need to set this to proximity for this to work. And I'm just going to boost it a lot to show you what I mean. As you can see now, by boosting this is creating nice, interesting shapes as all the particles are kind of going closer to each other based on this proximity and max neighbors that is set. I'm just going to set this to 3. Just a small little hint, as you can see when you're further away. It just creates a bit sharper shapes, which is always nice. And then I'm going to create a null and call it out core, as this is what we're going to point to in our render node. Okay, so let's set up the render for these particles. We can do that by going out one level and creating a geometry node, and I'm going to call this RNDR for render and core particles. And I like coloring these red. And what we can do is go in here, create an object merge, and point to our out core. And this is just a lot cleaner way to set up renders. Instead of pointing to this, we can point to a separate node which just has this out core that we set earlier and put this into our mantra. So I'm going to actually do that. I'm going to go in our out context so we can put down a mantra. And again, here I have a little bit of custom things that I am just going to reset quickly. Okay, so this should be all reset now in a normal mantra node. And I'm going to start by, in our objects, I'm going to remove our candidate objects. I like setting our objects explicitly and with the force objects. So if I can go here and select our force objects. I also just like removing the lights. We actually don't need any lights with this. And I'm going to call it core particles mantra. And if we try and render now, well, we actually can't even do that because we need a camera. So I'm going to control click on the camera, which will give me a camera where I'm currently looking. I'm just going to position the camera roughly. We're going to do this properly later. And let's see what happens when we try and render now. We're missing a material, so we're going to have some issues, but it might still give us something. Actually, it doesn't give us anything because we don't have any material. So I'm going to go into material, and I'm going to create a new tab called material palette, and we're going to scroll down into the constant material, which we will assign to our render node. So go to render, material, assign the constant material, and the constant material is just an emissive material, which just takes the particle scales in alpha of the particles and renders them out. And this is pretty close to what we have in our viewport, which is what we want. And we also, if you click A, you can see we have an alpha channel now. And I'm also going to turn on motion blur and set this to physically based rendering. And this won't actually do anything right now, but once we enable motion blur on our geometry node here, I'm going to save this snap so we can compare. You'll see that now this is being rendered with the motion blur. And close up, we might want more particles, but we're going to be a little bit further away, so this is totally going to do, and this works great. However, one thing that I noticed when I was working on it again is that the core is pretty empty, especially after we remove, with the fade alpha, we're even removing stuff on the inside. So I'm actually going to add in some stuff in the center by using the original sphere that we had here. So I'm going to put down a merge so that I can merge it in after the trail, and I'm going to object merge just to be clean this goal. I could just point it right there, but an object merge is usually cleaner than just a long wire. So I'm going to call it in goal again, and I am going to use another points from volume and figure out how many points I want here. Okay, so let's just Control C. So I'm going to turn this off so that I'm not locked into the camera. I'm going to go back into points. Actually, I find pixels to be even better to visualize points. And I'm going to set it to 0.005, which will give us around 4,000 points, which is around what we need. And the other scale to 1. Actually, I think we want a bit more points. So let's see. Maybe 2.5. 2.5 should be good for the amount of points we want. And let me just merge this in here. Shift R will switch the position, which is a bit cleaner. So we'll start with that. And these will just take up the same attributes as we created on our particles and blur them as well. And let's set this to disks. And this is a super quick way to get some more particles on the inside. However, these are very static, and you can clearly see that there's a line here of new particles. So I'm going to just create an attribute noise again to switch up these particles in the core a little bit. And I'm going to call this noise P because we're actually going to affect the position of these particles with this noise. I'm going to go to pixels and visualize this and turn off so that I can only see these objects. And what it's doing is streaking it like crazy because our element size and our amplitude is way too high. So I'm going to set our element size to 0.05 and our amplitude also to something lower like 0.1. And with that, you can see with the lower element size, the noise is a lot more controllable and something in range with what we have for our particles. But I'm also going to set this to 0 centered so that it's staying around the original object and not positive, because then it's just going to keep going in a positive direction, which is X and Y. And see, it's going to keep going kind of that way. But with that, we also need to enable animation so that this is moving in space and not just static. And I'm going to set the pulse duration to 0.3 so that it's moving pretty fast. And this might be a little bit strong. Let's see how it looks. Yeah, I think it's a little bit strong because you can see it kind of point out. So I'm going to set it to 0.07 and this maybe to 0.04. And that's going to give us more natural results, which won't stick out too much. And I think should work for our case. And the only thing that I want to change now as well is this won't have any velocity, so these will be very sharp, these particles. But if we use an attribute transfer, we can transfer the velocity from our sim. I'm just going to turn this off and write v here so that it'll transfer the velocity that we calculated. Let me drag this down a little bit. And now these will kind of be fake sim particles that'll look like they're part of the sim, but they're just generated on the fly and stop level like this, which is a nice cheat we can use. And now you'll see that this, if we go to, let's go to disks, looks a lot more integrated and doesn't look like there's some random particles being added. And we can render this again now. I'm going to go to the same frame 58, and hit render. And this core should now be filled in a way that doesn't stand out too much. There we go. And it's just a nice little addition to our core particles. And that concludes part 1 of this tutorial series. In the next part, we're going to create the tendril particles you very often see in Wanda's magic. So I will see you there.